I'm going to solve this problem with my pipe sizing calculator. I'm also going to solve it with MathCAD. This is MathCAD environment. I'm also going to solve it with Excel. What I get, I'll compare it with my pipe sizing calculator I created to see if the pipe sizing calculator is correct, is accurate. So invariably what I'm doing is to test my pipe sizing calculator with questions. So now let me solve it with my pipe sizing calculator. Let me open it. Recent let me run it. Respond it. Say this pipe sizing calculator using Calobricks white equation. Now it's customary because it's barrel per day, so you have 400 barrel. Let me just Control C. We are given Q, which is equal to 400 barrel per hour. Now there is no barrel in the units. There is no barrel. Let's go down to volume. V. Volume. There is no barrel here. We only have gallon and liter and milliliter. So now we needed to add that. So let me go to document. Let me click the document tab area. Now I'll just type BBL. I'll highlight this. I'll go back to Maths tab. Select, go to Style, select Units. Then I'll assign it. One barrel is equal to 42 gallons. So I'll just type in 42 gallon. So it's defined now. Let me minimize. Now, you know my pipe sizing calculator is in barrel per day. So let me use this to convert this to barrel per day. Let me see. Let me just let me come here. Just say Q equal to this. Now let me change this to barrel per day. We go to Math tab, change this to decimal. Now I can let me just change this to decimal instead of using this. So is 96,000. So let's go there. So here the kinematic viscosity is 0.88. The flow velocity is 96,000. The specific gravity is 0.736. The absolute pipe roughness is 0.002. The pipe length is 5,000 feet. The pressure drop is 27.24 feet. Now I say calculate. So this is what I got. So now let me use this. So let me delete this because this is not. Now let me list the parameters that was given in this equation. So now we are given specific gravity. Now I will say G for gamma. We'll use gamma for gamma symbol. So Control G means to change that symbol, that G, to Greek symbol. So I will assign the value. So I will say gamma. I will say column. Column means to assign a value. To define, just like when in VBA you define, you say dim, you define the variable. This one I'm defining the variable here now. So I'm saying 0.736. This one doesn't have a unit, specific gravity. So we have the pressure drop to be 27.24 feet. We have the length of the pipe to be 5,000 feet. So here the given values, I'm defining them here. Now the kinematic viscosity, I will say N, that is Control G, that is converting N to Greek value, which is this. I will assign a value of 0.88 centistoke. So centistoke is not part of it now. So now I will define it here. I will come here. Let me now change this. Okay, let me just type it value first. I will say C base. So come here, select this value, change it to units. Change it to units, then define the units. So this is the same thing as 10 raised to power minus 2 stoke, minus 2 stokes. So it's defined now. So now I will just say this is 0.88. So now then I will say E says A. Let me assign I will assign the value of 0.002. This should be in inches. This is the absolute pipe roughness. Now we are asked to calculate the pipe size, that is internal diameter, the radial number, the fluid velocity, and the friction factor. So what I'll do now, in order to do that, I will use solver. Excel has solver, this one also has solver, so I will just insert this solver here, expand it. Now here, let me expand this. Let me just take it up a little. Now I'm looking for D. Now I'll assign a value for D, which is 4, which is 4 inches. Here, so for here, I'm just guessing values. Just like here, I'm assuming values here. Now the Reynolds number, I will guess the value here too. Now I haven't gotten this. I supposed to use the formula for Reynolds number to calculate. I was supposed to use the formula for Reynolds number to calculate it, having given choosing a value for D, just like the way it is here. Just like the way it is in my this thing. So what I will do is I've assumed the value for D. I've assumed a value for D. Now let me just put that value here. So let's say D is assumed to be 4 inches. Now let's put the R. Let's assign R to be, okay, let me leave it at this. Let me leave it now. What I will do, let me just assign, let me assign 4,000 to this. You will see that the thing will not you see that the calculation will not, that it cannot be able to run, because I haven't assumed this. I'm supposed to calculate this with this assumed value. So let me just do it this way so that you understand what I'm saying. This is V. I will assign a value for V. Let me say it's 4 feet per second. Now I will assign a value for F. Let me say the value for F is 0.008. Now I will not say Reynolds number. I will say control equal to. Now this one I'm comparing. This sign is to compare. This sign I put in here is to compare. The one up there, that sign up here, is to define. Like this one is to define, just like in VBA you define. Now let me show you the operators. Let me see operators. Now let's look at it here. This one now, see, it definition. It defines the variables. Then now the one for, okay, this one now, you're comparing, you're comparing this and this, two variables. So you're comparing the equation. That is it. So now let me say this should be equal to, so from here we got this formula, having inserted the value for V, which is 4Q divided by pi divided by D square. So you now have that. You have 4, let me just say 4 divided by P control G, which is pi, now times D times N control G, then this times Q will give us Reynolds number, which is that. So now velocity equal to, that is control, equal to control plus equal to, I would say 4 divided by B control G, like changing it to gamma sign, times D raised to power 2. This is inverse of area times Q. So area Q divided by area will give you velocity. So this is for velocity. Now the next thing is we input the value for pressure drop. Pressure drop is H. I'll compare it. This is friction factor times bracket open L divided by D times, to press the forward key to take it out from the bracket open and close. So you say V raised to power 2 V square. You press the forward key so that you take it down, you take it away from the raised to power, so you divide by 2 times G. G is a constant, that which is acceleration due to gravity. Now I will also use the Colebrook's equation. So I will type in the Colebrook equation, which is 1 divided by, I click the backslash F forward, press the forward button 2 times, control equal to, now this should be minus 2 times log, brackets open. Now the logarithm, this logarithm, let me just explain it well for you. So now this, let's say I go to function this, I type in here logarithm. So that, let me explain what I'm using so that you will not get confused. Now these are logs. Now look at what I'm using. Now here is what the log of what, of the value, then here is the base. If you leave this place blank, it will assume it to be base 10. Let me just look at it here. Look at it. When you get the caution above that, look at what it is. It returns the base B. You see B, where B is in that log expression. Now the Z is a logarithm of Z to base B. But if you meet B, it will take it to base, it will assume it's base 10. So that means, let me close this. Now we are not putting any, we are not specifying the base. So we'll now say E divided by 3.7 times D, forward key, plus 2.51 divided by Reynolds number times backslash f. So this is let me just bring this thing down a little bit. These are the four equations I need. These are all the equations that I need to solve this. Now, based on this method, now because that is the same method I used to create that pipe size calculator. So now what I will do now, I will insert matrix of 4 by 1. I will insert 4 by 1 matrix. The up here will be, we're looking for D, we're looking for Reynolds number, we're looking for velocity, we're looking for what again, F. Now forward key, I will assign this to say find brackets open, I'll say find D, comma, find Reynolds number, comma, find V, comma, then F. So you see, the thing did not solve. So no solution was found. Try changing the guess value or the value of the tolerance. Now I don't think it should be the tolerance. Let me go there. The tolerance value should be calculated. Sorry. Now the tolerance value is -7. 10 raised to the power -7. This one I also make it 10 raised to the power -7. So I don't think it's a the issue there is, now having guessed this value, I need to use guess to also get this. Now let me copy this, paste it here, then change this to assign. Now I will now come here, I'll copy this and paste it here. Now let me say the Reynolds number now will be equal to this. So let me copy this value. This should be my guess. I'll copy it as my guess Reynolds number, so I'll replace it here. Copy it as my guess Reynolds number. I'll just paste. Then move this a little. Now what I'll do is to delete these ones because these are not. Now delete this. So let me bring down this to math. Okay, let me leave it. Let me leave it the way it is. So it's solved because I used the guess D to get this, the guessed Reynolds number. I didn't do that, it will not solve this way. So what I will now do next is to come down here, say my D is what is equal to what. Now I need to change this to inches. Now this is my D, this Reynolds number. Now let me change this to first nearest whole number. So now I have V to be equal to this. I have F to be equal to this. Now let me change this to 4 place of decimal. Let me see. This is what we get. So now comparing it with what I got from my pipe sizing calculator, I have internal diameter to be 14.51. So here is 14.511, so inches. Now I have my Reynolds number to be 6 for MATLAB is 693,431. Here is 693,840. So there's a little difference there. Then fluid velocity, I have 5.43. The fluid velocity here is 5.432, correct. The friction factor is 0.0144. Here is 0.0144. So the error here is just the Reynolds number. So that means I'll look at the next thing is to improve on this. So I'll look at the constants I use for this Reynolds number. That might be where the mistake is coming from, because these other things are correct. Let me check the pressure drop. Now the pressure drop in pounds per square inch. So I'll say P is the same thing as the density of the fluid, and the density of the fluid is the density of water times the specific gravity. Now let me just say let me use rho arrow control G for rho, which is density. Let me say that is density of water times G control G, which is gamma, which is specific gravity, times G acceleration due to gravity, times the pressure drop head. So now we don't know, we know the we know water density. So the water density, I will assign a value of 1000 kilogram per meter cube. So raised to power 3. So we have this. So the P will be equal to what? 8.69 psi. So 8.69. So here is 8.68. So it's correct. This is 8.69. That one is 8.6. So the pipe sizing calculator is correct. The only little discrepancy is here, which might be from the constants I used. So let me go over to Excel. Let me use Excel to also compare the results. Use Excel to compare the results. let me pause. So while this thing is loading, let me pause the video while this thing is loading. Okay, let me now start. So I've imputed I've put the parameters in which they give us as an input. So I will now do there are some calculations I needed to do. So I'll say calculate. So I'll say calculation. Let me just call it calculation. I'll select this, format paint, click here. So now I needed to change, I need to calculate all this in feet. I need all this I need all these things to be in feet, so that the unit feet will cancel each other. But using values that are not the units are not, but using it like this, you will not get the right value. So you need to convert everything to one particular unit. So this one is in inches, I need to change it to feet. So I'll need everything to be in feet before I proceed. Then now, like, I'll just copy the whole of this. I'll copy this, I'll paste it here. So I'll expand this. So this one now I need to change it to feet. This thing is I need to change it to feet, cubic feet per second. So this one I needed to change it to feet. I need to change it to feet square per second. So now to do that, let me just delete this. To do this, I'll say this is equal to, there's a conversion function here. So I'll say convert this flow rate, this value. I'll say comma, this value, comma. Let me be sure. Okay, yes, I press comma. I wanna press this. That is barrel. This. Okay, I didn't write this properly, so I say barrel here. Now I'll say comma. So the next thing that I will choose here is feet cube. So now this should be feet raised to power 3. Now I'll close the brackets. Now you know now I have changed this barrel to feet per cube, so I need to change the hour. So I will divide it. I will say divide by conversion, press the tab key, conversion, I press the tab key. I will say 1 hour, 1 hour, say comma, no, just say HR, no, this is wrong, HR, this, comma, this, I'll change it to seconds, this, so bracket close. Now I've converted it from barrel per hour to feet, cubic feet per second. So I'll just enter. So this is what we'll get. So for kinematic viscosity, I will just say this is equal to this divide by, now let me open, okay, the 1 centistoke is equal to, so now I will not divide it, I will multiply. I'll multiply it by, you know, 1 centistoke is equal to 1.076 E minus 5. Those E minus 5 is 10 raised to the power minus 5. So 1 centistoke is equal to 1.076 times 10 raised to the power minus 5 feet square per second. So I'll multiply it by that, so I will get this. So this other one I'm changing to feet, the absolute pipe roughness. So I will just say this is equal to, I'll use conversion again, press the tab key, select this, say comma, quotation mark, quotation sign. I can just say I will select this, then I select this other one, the feet there, because since I've written the units, it could work, it will still work that way. Okay, let me just do it, the same thing, but I can, let me just type it and say inch, quotation sign, comma, quotation sign, feet, quotation sign, I close the bracket. Now enter. So this is in feet now. So now I need to define all this. Now I'll make this one Q. I'll define this as Q. Say enter. So that is Q now. Now this one, oh no, I defined the wrong one. So let me go to formula and work it out. Let me go to formula now. This is the wrong one. So what I will do now is I will select this. I'll say equal to this one. This is Q. I'll click this sign, not the cross sign, this one. I've assigned that to when you look at this, you see it has changed. Now I can now add new one from here too. So they say the name, I will use let me use just V, small letter V for the name, which is this. Now I'll just say okay, so that one will enter. Let me put another new one now, which is, I will select this. Okay, let me select this. I'll call this E. So I will assign a value for E. So we'll have E as 5. This is 3. This is 4. So let me close now. Now we have, we'll now type in the things we, okay, now this one I will assign this, that should be length. I will use length. So that has been assigned. Now let's look at another one. I need to assign value for too. Okay, I need to assign value to pressure drop, that which is this. That should be pressure drop, and the pressure drop, the name. No, let me create, we want to save the changes now. Now the pressure drop C4, okay, this is pipe length. Oh, I didn't change that one, so now say yes. Okay, let me close this and look at this. I have length to be C4. Okay, now let me create another one. Select this, then come here. I will call it H. So I've gotten H, and then this okay, so I've defined this, oh, this 2 is in feet, so they are good to go. Now I'll close this. Now I'll come here, I'll calculate internal diameter. Calculate internal diameter. So internal diameter will be, I will use this formula here to calculate my internal diameter, which is this. So, and it's given here, so copied it and paste it here. So what I will do now is say, now I'll say this is equal to, I will say 8 times that means I didn't follow this, so I needed to assume a friction factor. So let's go back. Let me copy, because I'll still use, instead of typing again, let me say assumed friction factor. Now the assumed friction factor, I will assume it is 0.0 0.08. Now I'll calculate, this should be in feet because the whole parameters are in feet, so it should be in feet. So I say this internal diameter should now be equal to 8 times now be 8 times this, which is the I didn't put equal sign, so 8 times this times length times q, sometimes q raised to power 2 divide by h divide by 32.2, which is acceleration due to gravity in customary, divide by pi raised to power 2. Now I need to put bracket close here, put brackets open. Now I'll say raised to power, bracket open and close, type in here 1 divided by 5, so I enter. Then here I need to change this to a value now, but before I do that, let me define here. Now let me create new function, so I will call this f. It's okay. Now define f. So what I will now do next is I'll come here and I'll assign the value. So now I'll say using the formula, I'll come here, select f. Where is f? This is f. So there's there now. So I will now come down here. I haven't calculated this. I need to calculate the Reynolds number, because no, I call it Reynolds number. So here should be equal to, this is the formula for Reynolds number, equal to 4 times q divided by pi divided by d. Okay, not define this, so I will just select this, divide by v. I will define v, so I will say enter. Now let me define this, and I will define it as d. Now that's been defined. Now let me come here, cut it in this formula. So I will just bring down this and say I'll select it here, enter. So I've used it in the formula. Then here I needed to, let me open, okay, it's like I know it's offhand now. So this is, I'll write this as an equation. I'll read this one is the the color breaks equation. That is what I will write in here now. I'll say equal to 1 divided by the square root of f, bracket close. Now plus, because I will make, let me just pause and open where the formula is. Let me pause the video and open where the formula is. Let me pause. So this is the formula now that I'll key into this place. So what I'll do, I want to make it equal to 0, so I'll move this one to this side. It becomes plus, it becomes this plus 2 log e all over this is the base 10 equal to 0. So now I'm equating this whole thing. I'm moving this to this other side, I'm moving it to the left hand side. The whole of this are the right hand side to the left hand side, so that the right hand side will be 0. So that is what I'm doing here now. Say 2, this plus 2 times log to base 10. Press the tab key. Then I have e divided by 3.7 divided by d plus 2.51 divided by the Reynolds number. I have not defined this. Divided by the Reynolds number divided by the square root of f, bracket close, then bracket close again for the last one, enter. So I need to change this in the formula, but let me define it first. No, let me right click, enter. Let me define it first here with the Reynolds number. So I will define it as ROE. Let me see what it will work. ROE, okay. So in the equation, I will just select here, go to this, where is the ROE? I will enter. So I've defined it now. So then let me use this whole thing. Let me format this with this. So we have this. Then let me remove this here. Now, what are the results we are looking at? I'll come here. I will just write output. I'll write output. Let me make it in capital letter. The calculation is still output, but what we were looking at, I call it output here. Now we just select this, click this here like this. Then we are looking to get this Reynolds number, friction factor, and what again? Let me look at this. We have, okay, velocity is not here, so let me copy and paste. Now we have it like this. So now I will not say this is assumed. Now this is a real friction factor, so I will say this is equal to, this should be equal to this. Now the internal diameter should be equal to convert. Press the tab key, select this, comma, quotation mark. Then I will just say this is in feet. I'll say feet. Let's go from feet to this capital letter. So let me remove the capital letter. Feet, comma, inches, bracket close, enter. So this should be in inches. This should be in inches. Now the random number does not have a unit, so how I need to also calculate the velocity. So velocity should be in feet divided by seconds. Now the formula for velocity, I'll say equal to 4 times q divided by pi divided by d divided by d raised to power 2. Enter. Now this should be the velocity. Then the Reynolds number should be equal to this. Now let's begin by, let me now select this, select from here down, select this. Sorry, let me remove this. Now let me also remove the grid lines, so it will appear like this. I don't think I need, okay, let me still leave it. Let me leave this. Now let me go back to this. Now I needed to calculate this. I will use solver to do this. So I'll go to data, because I needed this to be 0 for me to get the right answer. So which is this, the output which I want. No, I will say data solver. I also need to calculate, let me come here. I also need to calculate pressure. I need to calculate pressure in PSI. So I also need to put the pressure in PSI. So let me just type PSI here. Let me make this capital letter. Let me select format paint and format this one. Now I need to move this one down here. Now put density here. That is water density. Water density. water density is 1000. This is in kilogram per meter cube. So format paint, or select format paint in clipboard. This now just format this. I'll come here, I'll just copy this whole thing so that it will help me to format it. Okay, let me just copy only this, copy, paste. Now I'll just format this too. Now I need to convert water density to pounds per feet cube. Now I will just say this is equal to convert this, comma, there is no kilogram, so I'm using gram. Say G, type G, repetition mark, comma, open. Now just say LBM this, close. So I have this, so I have gram. One kilogram is equal to 1000 grams. So for me to make this thing equivalent to 1 kilogram, I will multiply by 1000. Now I will not divide by, I need to change the meter cube to feet cube here. So I'll divide by conversion again. Converting one meter cube, converting 1 meter cube converting 1 meter cube, comma, to feet, feet cube. So converting 1 meter cube to feet cube, close brackets. Now enter. So I'll have 62.42. So this is pounds per. So this is in kilogram, this is in weight. So with this I don't need gravity, just like in this one I have gravity here. I don't even need gravity themselves. So that is it. So now that means I'll come here. So this should be equal to, okay, let me just change this so that when you look at the formula you understand what we are doing. So I'll go to formula bar, go to define, say new. Let me go back. Okay, define. Okay, look at it here, it's already here before, so I need to say equal to this. Click OK. Define now. say close. So I've defined this to be water density. So I will just say this is equal to this times H. So this value now is in pounds per feet square. So I need to convert this answer to let me escape. Let me come here so that where will be visible. But this is night, I'm not seeing clearly there. So I need to divide it by converting one. It's a 1 feet square. 1 feet square converting 1 feet square to inches square, all in brackets. So I have something like this. So I'm converting it to inches. So inches square. So it will be pounds per square inch. So I'll say enter. This did not get close to what. Let me see. The age is 27 divided by water density with this. Divided by this. So I mean this is okay. Let me leave it at this. So now I needed to work out this now. I needed to adjust this so that I will get this. I will get the other values. So I will use solver. I'll click data, go to solver. That has been selected. I want it to be the value of 0 should be 0. Then I should be changing this. I should be changing that. It's non-linear. Let me look at let me add more zeros. Now so I'll increase the accuracy. Now I'll say solve. So okay. So I have here as 0.0144, 14.51. This is correct. This is correct. But I'm having issue here. What should be the problem? What should be the problem? So this is 8 points. Okay, that one is here is 42.428, which is the same here. Is okay. Okay, I supposed to multiply this with specific gravity. I did not do that. Times specific gravity, because this is for water. So I did not multiply with the specific gravity, which is this. Which is this. So just say enter. So this is 8.69. So correct. Now I needed to change this to specific gravity. What will I define it as? Let me go to formula. Let me define that. Let me call it specific gravity. Let me say okay. Now let me come to this place. Let me go to here that I can see properly. I will now use the formula specific gravity. So I will enter. So it's still the same thing. So now I've gotten 8.69, which is the same thing with this, which is 8.69. okay, and then here in my own I have 8.68. Here is 693 800, that is 693,840. So this other ones, okay, this is 693,431, while Excel gives us 600. Okay, see, this one is closer to my own, so that means my own is somehow accurate. So that is that. This is what we got. So I'll stop the video here now. I'll stop the video here. Thank you for watching. Keep subscribing so that when I make new videos, you will be the first to access it and see it. Thank you for watching till the end.